Welcome to Sundar's lecture, and this is lecture number 41. In this lecture, we are going to see a numerical problem. Right? We will take a numerical problem, and with that numerical problem, we try to relate the concept whatever we have seen in the previous three classes. That means a resistor AC through pure resistor, AC through pure inductor, AC through pure capacitor, and AC through RL circuit, right? We will take up a few problems, maybe 2 or 3 problems to get a clarity about what we are actually studying, right? So before that, we need to go here to know what is Z values. We have not introduced Z values till RL circuit. In the RL circuit, we have introduced what is Z. Z is equal to R plus JXL, that we have seen. But before that, we have seen 3 topics, AC through pure resistor, inductor and capacitor. We have used only XL and XCs and Rs. We never used what is Z. But now we know what is Z. Actually, Z is the impedance value that will be combination of resistor and inductance. So that means maybe it may be a inductive reactance, not an inductance. Inductive reactance or capacitive reactance. Now let us we see this one now. See, we go here in the pure inductive circuit, right? What is the pure inductive circuit formulas come? In this formula, you see what is current I will be is equal to V by XL. And you see here at this point, here resistance R is equal to 0. R which is equal to 0 here. Try to understand. So if R is equal to 0, we know that I will be is equal to V by Z. We commonly say Z not a resistor, separately resistor, or we are not going to say separately what is the inductive reactance and what is the inductive capacitance unless it is a separate circuit. Anyhow, we commonly say now it is Z not XL, not XL. That you try to understand. Or you come here. If I write what is Z here, Z should be is equal to V by I. Z should be is equal to V by I. That I need to write clearly. So if I, what is this one? We have written I. What is I here? I which is equal to Im sine of omega t minus 90 degree. Or we can write this as, see, modulus of, not modulus, anyhow. See, Z can be written as, maybe Z can be written as V divided by modulus of I at an angle. What is this one? Actually, it is minus 90 degree, right? So what I can write here? I can write here, this is minus 90 degree. And also Z which is equal to modulus of V at an angle of 0 degree. This is reference. V is a reference. There is no degree. There is no pi value. So it will be 0. So I can write like this, modulus of I at an angle of minus 90 degree. So if I want to write what is Z now, see, modulus of V divided by modulus of I at an angle, commonly I can go for 90 degree. Plus 90 degree, right? It will be plus 90 degree. Z will become in inductive circuit, it will be plus 90 degree. So how I can write this one now? Z, you see, maybe I will write here to understand. To make things simple, I need to write this one. So here Z will be is equal to R. We know that R plus JXL. JXL. Why I need to put plus here? That is the very big question here. Whether I need to put plus or minus, that depends on this degree. What is this one? Plus 90 degree, right? Here it is plus 90 degree because in denominator it is minus 90. If I bring this to numerator, it becomes plus 90 degree. So Z will be always 90 degree. Z will be always 90 degree, right? No, this is not modulus. This is actually just Z, right? So I need to write here, maybe Z is equal to 0 plus JXL. Here, in the purely inductive circuit, I need to put plus since this 90 degree is coming in the positive way, right? Here, in current it will be negative, but what is the impedance? It is the inverse of current. So I need to put plus Z. So always I need to write Z is equal to 0 plus XL in the inductive circuit. And if I go for capacitive circuit, see, capacitive circuit, you see here, this is the value of I. So if I want to write what is Z, Z will be is equal to modulus of V at an angle of 0 degree, modulus of V at an angle of 0 degree divided by modulus of I at an angle of, and you see here 90 degree here. Here it is plus 90 degree. So if I commonly write, Z will be is equal to modulus of I by modulus of V by modulus of I minus 90 degree, minus 90 degree. Then what it will be? Z should be is equal to 0, maybe not 0. Let me write R here. Let me write R. So R minus jxc. Why I need to put minus here? Since it is minus 90 degree, Z will be minus 90 degree. Try to understand. In a purely inductive circuit, Z will be is equal to R plus jxl, and there R will be is equal to 0. Say if it is a purely inductive or purely capacitive circuit, resistor value will be 0. So commonly I can write Z will be is equal to minus jxc, minus jxc in purely capacitive circuit. If it is a purely inductive circuit, then R will be 0. So plus xl, that will be the Z value. That will be the Z value. And here you come now. So we will take up the problem now. So what is the problem given? So try to write the given data first. We will write it down. Given data. Given data. What are all the things they have given you? 318 microfarad capacitor is connected across the 240 volt 50 Hz supply system. See, first I will draw the diagram. First I will draw the diagram. Let me draw the diagram now. So there is a supply. So there is a supply, and in that supply we are giving two capacitors. One capacitor has been given. So capacitors has been given. So capacitor, one capacitor has been given, and that is connected to the supply. And what is this value now? This is a AC supply, and here they have given you V, which is equal to 240 volt. And what is the capacitance value? That is 318 microfarad, and this is a 50 Hz system, right? This is the 50 Hz system. So this is the given circuit, right? And this is a purely inductive circuit, right? To understand, there is no resistance. So obviously this is the purely inductive circuit. They are asking you to find what is the value of capacitive reactance. What is the value of capacitive reactance? See, here they have given you 240 volt. What is the 240 volt? It is defaultly VRMS value. It is defaultly VRMS value. So you write it down. So VRMS value, which is equal to what they have given you, that is 240 volt, and frequency, which is equal to, it is 50 Hz given, and capacitance C will be is equal to what they have given you, it is 318 into 10 to the power minus 6 farad. Since it is in microfarad, so we have written like this. Now they are asking you to find what is the capacitive reactance. What is capacitive reactance? To find Xc, what is the formula for Xc? We have seen Xc will be is equal to 1 by 2 pi Fc, right? That is what we have seen. So we will take up to inductive purely capacitive circuit. See, what is the capacitive reactance we have written? 1 by omega c, which is nothing but it is 2 pi Fc. 1 by 2 pi Fc. So we will write that one. So 1 by 2 pi F into C. So what is the value we know? So every parameters has been given. So 2 into pi into 50 Hz into what is the C? 318 into 10 to the power minus 6. So this will be the final Xc. And what is Xc? If I solve this, the value comes out to be around 10 ohms. 10 ohms. So this is the final Xc value that we have found. And what is the second one? They are asking you to find what is the RMS value of current. They have given you RMS value of voltage, right? They have given you RMS value of voltage. So let me write it down. So second question, we need to find what is the IRMS. What is the IRMS? And we don't need to write RMS value. So I have told you already, it is not necessary to write. Anyhow, to intimate, I have written here. Hereafter, I will not write. So this will be VRMS divided by modulus of Z. Modulus of Z, and we need to find this one, right? What is the value of modulus of Z? And what is the modulus of Z? or you need to find first what is Z here. Z will be is equal to, if it is a purely capacitive circuit, then minus J into Xc. Huh? Minus J into Xc. And what is this value? This value will be is equal to minus J into 10 ohms. Right? How will you write this one? Z will be is equal to 0 minus 10J. This is the value. I need to find what is the modulus of Z, right? To find what is RMS value, I need what is the modulus of Z. And what is the modulus of Z? How I can find the value of modulus of Z here? Modulus of Z can be found by, which is equal to square root of 0 square. That means you need to square these two values, right? Square root of 0 square plus 10 square. 10 square, right? So what you will get? You will get modulus of Z will be is equal to 10 square value will become what? Again it becomes 10 ohms. So Z value will be always 10 ohms. And what is the theta? What is pi? So you are just converting this rectangular form into polar form. Right? What is polar form? What is pi? Pi will be is equal to tan inverse of, what is this value? Xc by R, right? What is R here? R is 0. R is 0, right? What is Xc? Xc is minus 10. Xc will be minus 10, right? So what you will get? You will get here, that is infinity, right? Because R is 0 here. If R is 0, then Xc by R becomes infinity. What is tan inverse of infinity? Tan inverse of infinity, then pi value defaultly becomes 90 degree. 90 degree, right? So what is the Z value now? So Z will be is equal to modulus of Z at an angle of pi. And what we are getting, Z will be is equal to 10 at an angle of 90 degree. 10 at an angle of, sorry, this will be minus 90 degree, right? Minus. I have forgot to write, this is a minus 90 degree. Infinity will give you minus 90 degree, right? So Z value becomes 10 at an angle of minus 90 degree, right? So this is the final value. So we can substitute this modulus of Z to this IRMS is equal to VRMS by modulus of Z. So what we will get? So I will take a new page. So IRMS will be is equal to VRMS by modulus of Z. And what is the value we have got for this one? 240 divided by 10 ohms. And what you will get now? 230 or 240? What we have got? It is 240, right? It is 240. So what you will get? So this will be 24. So IRMS. So that is what we are asked to find. So I will write it down. So second question, IRMS will be is equal to 24 amperes. 24 amperes. So this is how you can write the expression, right? And you need to find what is the third question? Equation for voltage and current. Equation for voltage and current. So question number 3. How will you write the equation? So V will be is equal to Vm sine of omega t. That we know, right? That we know already. And I will be is equal to Im sine of omega t. What you will get? In purely capacitive circuit, this will be plus 90 degree. Plus 90 degree. That is what we have already seen. But we need to find what is Vm and Im. If you know both expressions, then we can write directly these two expressions, right? What is Vm? Vm will be is equal to square root of 2 into VRMS. Right? We have seen this. What is VRMS? VRMS will be is equal to Vm by root 2, that we have seen. So this value becomes root 2 into 240. And what is Vm we will get? Vm will be is equal to, so this value comes out to be 339.41 volt. This is the final value. So how we can write this expression now? So V will be is equal to 339.41 sine of omega t. Right? I can write like this. And if you want to find what is the value of current, Im will be is equal to what? square root of 2 into I RMS. So I can write this one square root of 2 into 24. So what I will get here, so I will write it in a different color. So IM will be is equal to, this value will be 33.94 amperes. So finally I can write I, which is equal to 33.94 and then sine of omega t plus 90 degree. So this is the value. Or this 90 degree, we have written here defaultly because we know that it is the purely capacitive circuit, but you can get it from here. Whatever the value you are getting from the impedance value, the pi value, that will be the pi. So you can also get it from here. Right? Not an Z. If it is a Z, then it will be a minus 90 degree. So what is the current value? The current value will be the inverse of Z. So it will be the positive 90 degree here. We have written like that, right? So this is how we need to solve a problem in purely capacitive circuit. Let us we take another problem related to purely inductive circuit, and we will go for RL circuit. So we will get a good ideas that we will see in the next class. Thank you.